Thank you, Francesco, for introduction as well as for inviting me as a speaker on behalf of the Foodie Project Consortium. The slight complication is with my name and especially my surname because it's a tongue twister. Maybe you can try. It's a Tomáš Řezník. But since it's too complicated, just call me Tomas whenever you want to. I'm also facing to another problem, I suppose, because I got the first presentation after the lunch, which is always the most demanding one for all in the audience. So talking in the project terms, I would say that my measurable objective during my presentation would be to not let you fall asleep. I hope that this will be true. Since I'm coming from the academia and I'm also part of the Wireless Info professional body, which is the integration of the academia, of the commercial sector and also the public sector, I start with the academic approach, so it means the use terminology. So as Francesco introduced, the foodie could be just a small quiz for only one slide. A person who is seeking for new food experiences rather than just having a hunger. B, it could be a project targeted to support farm-oriented open data in Europe. Or C, it could be a cloud-based infrastructure that is being developed to support farmers across the European Union. Do you know the answers? A, B, and C are correct. So this is a very nice situation that everybody has truth. So going to the real content of the presentation. First, I will skip motivations. Since they were already presented during the morning sessions. I will slightly inform you about the project background, and then I will move into more detail about the pilot studies, especially the Czech pilot study, and move to the foodie data models, since the name of my presentation is about the data models, and then I will go to the conclusions. So as I have said, the motivations are clear. There has been discussed the whole morning. We have heterogeneous information, and even if there are some attempts to standardize it, it is still heterogeneous. Very nice example is the LPIS data, the land parcel identification systems, because we have standardized and unified 45 systems across 28 European member countries. So as you can imagine, several countries have 2 or even more systems. So the information is really very heterogeneous, distributed, and so on. About the project background, we are after the first year of the project, because we have started in March 2014. So we are 3 years project with 13 project partners from 7 European countries. And just to briefly inform you, we are, as almost all projects, bounded with the project management on one side and with the dissemination on the other side. Our founding stone is the service platform specification. That means the identification and establishment of the concept. Then we have one core application work package, which is the development of the cloud infrastructure and integration of all data sources. In parallel to this, there has to be the data analysis and also modeling and other things I would like to briefly present you later on. And all of this should be verified within the pilots. So regarding the pilots, we got 3 pilots. The first one is in Spain, very specific one because it's dealing with the vineyards in Asturias region. It's Taras Gauda, partner, who is responsible for that. Then we got the second pilot in the Czech Republic, which I will present in a detail. And then we had a third partner, third pilot, which is a very specific one because it's conducted in Germany, even though we don't have a German partner. So it's performed by the Austrian partner, by the Progis. Maybe you know Walter Meyer, who is a very famous person of that company, a very talkative one. So they are dealing with the integration to the fleet management systems. And as I have promised, I will inform you about the Czech pilot study. Perhaps you know where the Czech Republic is. So it's plus minus this bounding box. And we got 2 farms. Both farms are operated by MJM Litovel, which is the company in the project consortium. And it's the supplier for the end users. So the farmers could use the service from the MJM Litovel, which means a service like complete production and everything related to the production, or they can also have only some advisements which could be paid. And we have 2 verifying farms. The first farm is the Tršice. The lower one is located in the lowland, while the farm Weiglov is in the highland, in the start of the mountainous area. So you can see the details. You can see that they are also different, where one supports the organic farming while the other don't, and so on. And the Czech pilot, together as the Spanish and also similarly to the German one, have 3 scenarios. The first scenario is to improve the efficiency of the transportation of a large organization, which is for the MJM. The second one is the telematics of the farm machinery. And the third one is the optimization of crop management. So we are dealing with the variable rate applications and so on. So the scenario 8, improving efficiency of transportation. As I have mentioned, the MJM acts as a service or could be hired as a service. So it can offer you fertilizers, it can offer to a farmer pesticides, other materials, and they can offer just those products, and they can offer also the full service, including the production on the field. And there's a legal obligation, and the legal obligation is to take back the empty packings. So for that reason, we have to also deal with that. So the improving efficiency of transportation is not the autonomous driving and something like what was presented in the morning, but it's really how to get to the field, how to deliver there the pesticide, fertilizers, and so on, and how to obtain them back. So it should be a new system, a subsystem of the foodie platform, as we call it, that should deal with that. Then we got the telematics of farm machinery, which is very similar to the approach that was presented, or approaches that were presented in the morning. So the real example, for instance, for the trajectories and so on. And one reason that why we are dealing with that was something that was also emphasized in the morning, and it's the agro-environmental limits. So we have here the nitrate directive, we got the water framework directive, and so on. And we have to also have the evidence of the pollution. The scenario C is the optimization of crop management. So we are using the satellite data. So far we are using the Lancet data. We are using the vegetation indices, also the RTK stations. Maybe one difference that is in the Czech Republic, since we have the heritage from the past, is that we have very big farms, I would say. It's not a problem to have 8,000 hectares to have a farm. So for that reason, according to the graph that was presented in the previous section, you can imagine how the costs are really going down. And so for that reason, we got also several farms that have their own RTK reference stations. They are providing their own, because it's really cost efficient. Together, it's accomplished with the ground information from the meteorological sensors and so on. So, for instance, the MJM Litovel is doing the variable rate applications and also the indices and everything related to that since 2000. But I would like to move to the things that are really opened. Because traditionally, when we talk about no matter whether it is a geographic information system or a farm management information system, we say, okay, this, or especially some seller or reseller would tell you, of course, the system is interoperable, this system is open one, and so on. But it usually means that the models are proprietary and hidden. The data model is hidden and you don't have access to this. And what is available is the open exchange format. And this is something which we would like to change. This is one of the motivations also for the project. And so we have developed several data models. As it happens to all data models, it has usually 3 stages. The first one, you get primitive data model, which has the brief ideas about the problematics you would like to model. Then you get a very complex one, which could not be used. And then you go into simple one that is capable really to resolve your problems. And we are going towards to that. I cannot say that we are finished yet, but so far after the first year, it looks this way. So it contains, unfortunately, it's not readable, but if you know what to read, you can read it. You have the different hierarchical levels. First one, you start with the farm and with so-called farmers blocks, just to have the connection to the LPs or LPCs. And the second motivation to have those hierarchical levels is that we would like to be compliant to the INSPIRE directive, to have the interoperable data model. So if you know the directive 2007/2/EC, which is the INSPIRE directive, it says about the interoperable data models, and there is some theme, spatial data theme, that is called agriculture and aquaculture facilities. And this is what we took as a beginning, we took as a founding stone, and to which we add the plot level, the management zones level, so we could identify the pH, organic matter, soil type, also electric conductivity, and so on. We got all kinds of interventions, so everything that was conducted on a field. Also the treatments, so the intervention could be without a treatment, of course, like for instance a tillage. And whether it suits to the treatment plan as planned for the season, and also going down to the product level, just to have identified the product which was used for the treatment, and the amount of the product from the sensors. So a farmer would have a direct evidence for other directives or other legislation. Then, beyond something that I have just presented, and we call it as the core data model, we have something that is called the sensor data model, which is also compliant to the ISO standard, observations and measurements, 19156. And simply it says that you get the observation, but this is not what you just receive, because you get usually some property and values like temperature or height of a crop or whatever, and the values, 30 meters or something like that. But you are also describing what you have measured and how. And for those who are technically interested, this is the interoperable encoding according to the ISO standard. So the first, you get the description, what you have to expect, what does it mean, the first value, second, for instance, temperature, how it's measured, and so on. And you get something which is called the data sentence. So this is the measurement itself. As the third open data model, we got the transport data model. This is especially for the empty packings and also for the delivering of the pesticides and fertilizers, because we are following, of course, the graph theory. Graph theory, so we got the vertices and edges. And we have tried to convert, and so far it seems successfully, the OpenStreetMap as the open source for the transport networks into the data model that could be used for the navigation of those vehicles that are delivering the pesticides, fertilizers, and so on. And So the data model looks like that we have following attributes, like the identifier, national code, road width, height, of course, maximum weight, speed limit, which is not a problem to receive from the OpenStreetMap. Slightly problematic is with the surface category, and the biggest problem is with the hazmat limitation, the hazardous materials limitation, because so far this is not a part of the volunteer geographic information provided in the OpenStreetMap. So we have a mechanism how to enhance the information, for instance, through a cell phone or through a web client. But anyway, this very significantly depends on the farmer or any data provider. So if I will go to the conclusions, just try to summarize this really overview presentation, because there are a lot of issues that are dealt with that. The biggest difference, I would say, between the other systems, because several of that was already presented, several of that is really available. But this is the solution that is open one, that is scalable, and that will be offered to the farmers. And the second difference is that we tried as much as we can to respect several framework initiatives, like for instance the Inspire, also Copernicus, and so on. I'm also proud to say that we have been successfully registered into the GEOS, into the Global Earth Observation System of Systems, under the architecture pilot number 8, which is dealing with the water and agriculture pollution. So for that evidence, our platform and our project was taken as a pilot one. So we are trying to be a part of the broader point of view. Of course, we got several disadvantages. It's reasonable and it's obvious, I say, that a project like this has several disadvantages. The first one is that we got several kind of data that need to be integrated, and not everything could be integrated during the funded project phase. And also, the biggest problem, at least so far I see, is the distrust of the end users. Because traditionally, when you have any information system that is dealing with big data or something like big data, and try to imagine that you would have at one place in one database or replicated databases, no matter, in one platform, several data from several users. And for that reason, it's a very small step to misuse those data, because it could give you very significant advice and advantage on the market. So this seems to be the biggest barriers, as we have discovered during about 2,000 involved farmers so far. So that was briefly all about the Foodie platform, about the Foodie project. I would like to thank you for your interest into this presentation as well as the whole workshop, and looking forward to your questions, no matter now or later on.
Thanks for the presentation. Are you also planning to have a data model for transition from existing systems to this system? If I already have something running, how do I move from what is existing to what you're doing?
In fact, there are two ways. The first one would be just to have the interoperable data format. So if you would like to only transfer your results from your system and you would like to stay autonomous. So for that reason, if you will stick to the open formats that are recommended by those directives, which means the geography markup language, JSON or GeoJSON, then it could be. But the more tight way of the integration would be that we have also the import interfaces. We have the data harvester, which is the RESTful API, the application programming interface. So we can stick to your RESTful API if you got some. Or we can use the interoperable web services like the OGC web feature service. There are two ways. The first one, if you get some software, you can integrate it into the Foodie platform since you follow the standards. And also, there is the other way that you can integrate the Foodie platform into other system, which is also feasible, just to respect almost the same standard. There are several of them, but it will be for a separate presentation, I'm afraid.
Thank you. Thank you, Tomáš, for your presentation. I see on this slide you have Atos in your consortium. Can you maybe elaborate a little bit on their involvement and what they are doing to get this one step further?
It's a very easy question because Atos is the coordinator, so he's the leader of the whole project. So a Spanish company, Spanish IT company, and they got also their own business in the precision agriculture they are running. So they are trying to transfer their experience also to this open platform.